Good morning, everyone. It's me, Arjun Fokhrel. Welcome to you all in my online class. Today, I am here with the final part of the fourth chapter from class 10. Today, I am here with the final part of the fourth chapter. And in this class, we will be discussing on the topic. In this class, we will be discussing on the topic weightlessness and freefall. Okay, in this class we will be discussing on the topic weightlessness and free fall. Two topic. First of all, free fall. First point, free fall. When the body is falling only under the effect of gravity. When the body is falling only under the force created by the Earth or any other planet, without external resistance, the fall of the body is called free fall. Okay, when the body is falling without external resistance, with only gravity, then fall of the body is known as free fall. For example, when we throw a small piece of stone from the roof of the house, then after such stone fall on the earth, without any external resistance, without resistance of the air, then in such condition, the fall of the body is known as free fall. In this diagram, a parachute is given. Due to presence of air resistance, the motion of the man, when the man jumps from the parachute, the motion of the man when the man jumps from the parachute goes on decreasing because of the air resistance. Acceleration produced on the freely falling body is equal to the acceleration due to gravity of the planet at that condition. During free fall, acceleration produced on the freely falling body is equal to the acceleration due to gravity of that planet. For example, in case of moon, acceleration due to gravity of the moon is 1.63 meter per second square. It means in this condition, the acceleration of the freely falling object on the moon is 1.63 meter per second square. Acceleration of falling body is equal to acceleration due to gravity during free fall. That is A is equal to G. A is equal to what? G. But if there is air resistance, the situation of free fall does not exist. If there is air resistance, free fall does not exist. In the parachute, free fall does not exist because of air resistance. In the parachute, free fall does not exist because of what? Because of air resistance. Thus, if there is no free fall, then acceleration due to gravity is always less than acceleration due to gravity. If there is no free fall, then acceleration is less than the acceleration due to gravity. Less acceleration than acceleration due to gravity. Some of the examples of free fall. First example, the fall of an object on the moon, where there is no atmosphere, no air. On the moon there is no air. Due to no air, free fall is possible on the moon. Every object fall with the acceleration equal to acceleration due to gravity of the moon. Okay, in case of moon, every object fall with the same acceleration as the acceleration due to gravity of the moon. The fall of an object on the moon where there is no air resistance. Likewise, the fall of an object in the space where there is no gravitational force, no effect of gravity. Okay, in the space there is no effect of gravity. At that condition, the fall of the body is also free fall. Another example of the free fall going to be noted, a body falling in the vacuum. Okay, a body falling in the vacuum. In the vacuum, there is no air, and every object fall with the same acceleration as the acceleration due to gravity of that planet, of the earth, of the moon, etc. A body falling in the vacuum. These three examples I have mentioned here. One question: the parachutes are not hurt when they jump out of an aeroplane. Why? Parachutists are not hurt. Okay, parachutists are not hurt. They do not have any problem. Okay, when they jump out of an aeroplane. Why? What is the reason behind it? Now, I'm going to tell the reason of this question. When the parachutists jump out of an aeroplane, they accelerate under the effect of gravity. Okay, when the parachutists jump out of an aeroplane, they accelerate under the effect of gravity. They move, okay, under the effect of gravity. When they open the parachute, as the parachutist open the parachute, the air resistance slows down the speed. Air resistance slows down the speed once the force of air resistance balance the force of gravity. Listen. Once the force of air resistance balance the force of gravity, the parachutist no longer accelerate. Okay, due to reaction force created by the Earth atmosphere. Okay, due to reaction force created by the Earth atmosphere, parachutes do not accelerate. Okay, do not what? Accelerate, no longer accelerate, and calm down slowly, slowly. And calm down slowly, slowly. Then after, parachutists, okay, are not hot. So the parachutists are not hot when they jump out of an aeroplane. This is very important question that you need to remember. Another, the parachutist will fall freely on the moon. Sorry, the parachute will fall freely on the moon. Why? Because there is no atmosphere. Because there is no atmosphere. In case of moon, one cannot land safely because there is no atmosphere, no air resistance. Okay, then the parachute will fall freely. Motion of the parachute, acceleration of the parachute equal to the acceleration due to gravity of the moon. Okay, acceleration of the parachute equal to the acceleration due to gravity of the moon. There is no effect of parachute in the moon. Person cannot jump safely in the surface of the moon. Person cannot jump safely in the surface of the moon because there is no air resistance, no reaction force. But in case of Earth, due to Earth atmosphere, reaction force is created and the person can jump safely. Okay. Another question, the probability of getting hurt is more when one falls from the significant height, greater height. When we jump from the greater height, significant height, from the top of the roof, the probability of getting hurt is more in comparison to the probability of getting hurt when a person jumps from a lower height. Because the ground striking velocity, okay, ground striking velocity while falling from a significant height. The ground striking velocity while falling from a significant height will be more, and therefore the effect of force also will be more. Therefore what? The effect of force also will be more force. beta force also will be more. Okay, that's why the probability of getting hurt is more when one just from the significant height. Now I'm going to discuss the another topic, that is weightlessness. Okay, this is the final topic of the fourth chapter. This is the final topic of the fourth chapter. When the body is in the state of zero weight, no weight, when the body is in the state of zero weight, then it is called weightlessness. When the body is in the state of zero weight, then it is called weightlessness. Weightlessness is the condition. Okay, weightlessness is the condition in which the weight of the body seems to be zero. Actually not zero, but it seems to be zero. A body with a fixed mass will be weightless under the following conditions. Conditions of weightlessness. Okay, conditions of weightlessness. When a body falls freely under the influence of the force of gravity only force of gravity. When the acceleration of a falling body is equal to the acceleration due to gravity. Acceleration of the falling body is equal to acceleration due to gravity. When a body is at the center of the earth, okay, there is no acceleration due to gravity at that condition also. Another, the body is in the artificial satellite or rocket, becomes weightless. Okay, while orbiting around a heavenly body. While orbiting around a heavenly body. Now I am going to tell the difference between weightlessness and free fall. Free fall and weightlessness. Free fall. When the body is falling only under the effect of gravity without external resistance, the fall of the body is called a free fall. Weightlessness. When a body is in a state of zero weight, it is called weightlessness. Free fall is the cause, weightlessness is the effect. Okay, free fall is the cause of weightlessness. Okay, weightlessness occur due to free fall. Weightlessness is the effect of free fall. Weightlessness occur due to free fall. Free fall is the cause of weightlessness, and weightlessness is the effect of free fall. Okay. Many students have asked me about the numerical problem what I had given yesterday, and the problem is Mount Everest is 8,848 meters above the sea level. Find the acceleration due to gravity at this height. The value of acceleration due to gravity at the Earth's surface is 9.8 meters per second square and radius is 64 kilometers. Question, listen once again. Mount Everest is 8,848 meters above the sea level. Find the acceleration due to gravity at this height. The value of acceleration due to gravity at the Earth's surface is 9.8 meters per second square. 9.8 meters per second square. Its answer is 9.75 meters per second square. I'm going to solve this problem here. Here, acceleration due to gravity. Okay, acceleration due to gravity at the surface of the Earth, that is g is equal to 9.8 meters per second square. Given, okay. Then radius of the Earth. Radius of the Earth r is equal to 64 kilometer. We have to convert 64 kilometer into meter. That's why its value becomes 6.4 into 10 to the power 6 meter. Okay, its value becomes 6.4 into 10 to the power 6 meter. Height of Mount Everest. Height of Mount Everest is equal to 86,848 meter. 86,848 meter. Acceleration due to gravity. Acceleration due to gravity at the top of Mount Everest, g prime, is equal to what? Acceleration due to gravity at the top of Mount Everest, g prime is equal to what? Okay, we know that acceleration due to gravity. Okay, acceleration due to gravity at Earth's surface. G is equal to capital G capital M by R square. Capital G capital M by R square. That is the formula to calculate acceleration due to gravity at the surface of the Earth. Again, acceleration due to gravity. Okay, acceleration due to gravity at height h. Okay, G prime is equal to capital G capital M by R plus H whole square. Okay, capital G capital M by R plus H whole square at height h. Okay, dividing equation second by equation first. Okay, dividing equation second, this equation, by first equation, this equation. Dividing this equation number second by equation number first. Okay, dividing this equation by this equation. Okay, G by G prime. Equation second by equation 1. G by G prime is equal to capital G capital M by R square divided by G capital M by R plus H whole square. Okay, G R plus H whole square is equal to G by G prime. Here you have to write R plus S whole square by R square. G prime is equal to G into R square by R plus S whole square. Putting the value of G R here 9.8 into 6.4 into 10 to the power 6 whole square by 6.4 into 10 to the power 6, that is the value of G, plus 8,848 square. Then G prime is equal to 9.75 meter per second square. Hence, the acceleration due to gravity at the top of Mount Everest is 9.75 meter per second square. Acceleration due to gravity at the top of Mount Everest is 9.75 meter per second square. Thank you, dear students, for watching. In this way, the first chapter is over, and in the next class I will teach another important chapter from biology, that is the life cycle of silkworm, first part. Thank you.